Hi everyone, just wanted to take a minute to talk a little bit about angle side angle and angle angle side triangle congruence. These are the next two methods we are going to use to prove triangles are congruent. So as a recap, thus far we have talked about side 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 and side angle side. As you can tell, we're moving into the realm of having two angles now, and then we will have one more after this that we'll cover a little bit later. But as a reminder, this will be going along with the notes that we also cover in class, and it'll help you fill out the note sheet. So if you have any questions, please do feel free to reach out, and also make sure to double check the slideshow and also this video to help you out. All right, so what are we actually doing today? Well, we are going to be proving triangles are congruent using angle side angle and angle angle side. All right, so let's start off with angle side angle. And this is basically very similar to our side angle side, except now instead of having two sides at an angle, we have two angles and a side in between. So we do have to be careful. This is angle side angle. So when you're looking at your triangle, you should look at it and go, we have an angle, we have a side and another angle. So the side needs to be in between. It needs to be the included side. And if we have that between the two triangles, then we can say that these two triangles are congruent. Again, this is a postulate, so we do not need to prove it. This is a thing that we can accept. And ultimately, what you're going to be doing with these proofs is very similar to what you've been doing. You just have to keep track of what you have, right? So before, when we had side, 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 we were just looking at sides. Then we had side, angle, side. Now we introduced angles. And any of the methods that we had previously used to get angles, parallel lines, perpendicular lines, vertical angles, anything like that, angle bisectors, those are still going to be available to get angles for you, but now you have two angles. All right, so let's look at this example. So we're given that that side PQ is parallel to side RS. So right there, see, as we said, parallel lines are going to give us angles. And then we have that angle PRQ and angle SQR are congruent. So my other recommendation to you is if you have something next to you, like a piece of paper, a whiteboard, any sort of something that you can write on, just draw a quick picture and sketch it out. That way you can see what you already have. So obviously we have an angle here, and it's congruent to this angle. Just from inspection, looking at this before we even read what's going on down here, I know, the parallel lines, as we've discussed in the past, are going to give you an angle, and it's usually coming from alternate and interior angles. And then also, you can just look quickly and see there's a shared side, right? Whenever we have a shared side, it's great because that means we're going to be able to use the reflexive property. All right. So looking at what we have our given information. We have our two givens. We are going to use the parallel lines here to get alternate interior angles to say that these two angles are congruent. All right. And remember, when you have parallel lines, right, when they're in between them and on opposite sides of the transversal, they're alternate interior. So there's a nice little recap for you. So now we have these two. So we have two angles, and this side right here is a shared side, so we can use the reflexive property. So there we have an angle, side, angle, angle, side, angle. All right. So there you have it. Now, let's do this one. This is a little bit more practice, but we're just filling in the blanks. So again, as you can see here, we have perpendicular lines this time. Perpendicular lines, as a reminder, do offer a possibility for you to get angles, right? Because perpendicular lines make right angles, and right angles are congruent. We have that segment BD is bisecting segment angle ABC. So because it's bisecting an angle, that's going to give us some angles. And then just from looking at our picture, we can already see we're going to have reflexive. All right. So what are we given here? Well, we're writing down our givens. Then we have this first question mark, and it says the definition of perpendicular. Well, what does perpendicular give us? Give us that right angles are, it gives us right angles, right? And that would mean angle ADB and angle CDB are right. Okay, so they're just right angles. All right, so that comes from the fact that they're perpendicular. Now, we're saying that these angles are congruent. Well, why are right angles congruent? Well, all right angles are 90 degrees, and therefore their measurements are equal. And because their measurements are equal, they are all congruent. So you can just say that all right angles are congruent. Okay, now we have that ABD, angle ABD, and angle CBD are congruent. Well, so we have this side and this side. Now we're saying that these two are congruent. Why can we do that? Well, what were we told up here? We were told that this bisects. So that just comes from the definition of a bisector, right? That's all it means to bisect. It cuts it into two equal parts. Now, we have an angle, we have another angle, and the side in between them is shared. BD is congruent to itself. So by the reflexive property, we can say that these two are congruent. All right, so now we have an angle, a side, and an angle. Angle, side, angle. So we can say the triangles are congruent, and our goal is to prove the triangles are congruent, right? So triangle ABD, and do remember that order matters. Triangle CBD are congruent. And that's all there is to it, all right? So I think these are things that you've seen before. It's just now you have more angles than you have sides. So it hopefully won't be anything super new or anything super crazy. I think you can manage it. All right, let's look at our next thing. So now, as always, we're going to go on to the process of actually proving it all out. So let's go through statements and reasons here. Okay, so I'm going to go with the given. CAB is congruent to DA. Whoops, I forgot the angle. DAE. You know what? I'll leave them separate so we can see them. All right, AB, segment AB is congruent to segment AE. Let me just mark that off. That's my little recommendation to you as well, just to remember to mark them off so you know what they are. All right, now we are told that angle ABC and angle AED are right. So we have our three pieces of given information. Now, these first two, this is just giving us an angle and we're saying angles are congruent. This one's just telling us that sides are congruent. And this last one is actually something we can do something with. So we are told that we have two angles that are right. Well, what do I know about all right angles? They're congruent because they're all 90 degrees. So angle ABC is congruent to angle AED. And again, same thing, all right angles are congruent. All right, so we have that all angles are congruent. So that means I have these ones, and well, what do we have now? We have a angle, side, angle. So we're done. We just have to prove that the triangles are congruent. Triangle ABC, congruent to triangle AED by angle, side, angle. And we're done. All right, so these are all things that you have seen before, all right? So don't get tripped up on anything. It's nothing new. It's exactly what you've done in the past. So please, 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 please let me know if you have any questions about angle, side, angle. Normally, we were only going to do one at a time, but the other one that we have that we're going to talk about today is very similar, and that's why we're going to do it together. Because it's essentially the same thing. It just matters where the other angle is. All right. So the next thing that we're going to do is we have angle, side congruence theorem. Now this is a theorem, so we will have to talk about why it's true before we actually use it. But Basically, it's the same thing that we just had, except the only difference is that now it's the non-included side. All right. So see how before when we had this, we had something like this, angle, side, angle. Well, now our side's over here, or it could have been over here. It doesn't matter. But it's one of the sides that's not in between the two angles. So you should read it as angle, angle, side. Okay. So you have the two angles and then the side not between them. And that's the only difference. All right. The only difference between what we just did and what we are doing between angle, side, angle, and angle, angle, side is literally just the order of where the side is. So it's nothing new. It is a theorem, though, so we do need to talk about it. So the reason why it's true is, well, what do we know about all triangles? Their angles add up to 180 degrees, right? So if we know that we have these two angles are congruent, and we have that these two angles are congruent, right? We essentially, if we set them equal to each, right? Because this plus this equals 180, and this plus this equals 180, but this is the same as this, and this is the same as this, so we can cancel those out. So essentially that just means that this angle and this angle has to be the same. So that's something called the third angles theorem, which basically just says if I know that two angles are congruent, I clearly know that the third angle is congruent. And because I knew that the third angle is congruent, right? The third angle is congruent. Essentially, that means I could just do one more step and say angle, side angle. So why is this true? Because if I know two angles are congruent, I know three angles are congruent, and then I could use angle, side angle. All right. So in your note sheet, it asks you, why is that true? Well, you know it's true because of the third angles theorem, saying that if you know two angles are congruent, you know the third angle is congruent and could just use angle, side angle. All right. Now let's actually go through and look at an example of it. So based on what we know, once again, same thing, parallel lines are going to give us angles, and then we're also given angles. And you can look and see we have a shared side, so reflexive. Now, alternate interior angles, once again, are going to be what we are able to do. Let's just also mark off what we have. So we have that. And then we are using alternate interior angles to get these two angles. So we have an angle, angle, and then our shared side is reflexive. So it's an angle, angle, side, angle, angle, side. All right. So remember, the side is not in between anymore. All right, now let's do this one. This is another fill in the blank. What do we have going on? Move my head over there. So, okay. So what are we told? We're told that AE is bisecting BD. Now you need to be careful because this one is saying it is bisecting a segment, which means it is a segment bisector and will give you a segment, not an angle. Then we are also told that these two are congruent. That's marked off. All right. So our first thing, obviously, what do we start with? Well, we start with what is given. But that's only half of the givens, right? That only covers this part. The other part of the given is listed below, and it's the AE bisects BD. All right. Now, AE is bisecting BD, so that means BD is getting cut in half. So this part and this part are congruent. So BC is congruent to DC, and that's just what it means to be a bisector, right? All right, so let's see. What do we have now? Well, we have that angle ACB, this angle right here, is congruent to angle DCE. And that one is something that we know. That's just vertical angles, right? Don't forget, whenever you have them kind of forming that like X style formation right there, you can use vertical angles to say that the opposite ones are congruent. All right, and then finally we have, well, what do we have? We have an angle, angle, side, angle, angle, side. So that's why we're able to say that these triangles are congruent. All right. So it's, again, very similar. All the same things that you've done in the past, except now the angles are outside, and then there's the side on the other. Sorry. The side is just not between the two angles. All right. Last thing that we'll do before one quick last final explanation of something. Let's look at this. We have our statements and our reasons. Okay, so what are we given? Well, I'm just going to write the givens together on this one. I'm too lazy to write them out. Okay, so we are given that these two lines are perpendicular, right? These two right here. And remember, perpendicular can only mean one thing, that we have right angles. And then we're given that these two angles are congruent. Okay, so that is given. All right, so we have these lines are perpendicular. Well, what does that mean? That means that angle RGM and angle RGT are right. And that just comes from the definition of perpendicular, right? So that's all that this means. It means that these two angles are right. And since we just said that they are right, we can use that same thing that we've done in the past. All right, we can say that now they are congruent. And we can say that they are congruent because all right angles are congruent. All right, now what do we have? So we have an angle, and what do we know about RG? Well, it's a shared side. So we can use reflexive. All right, so now we have successfully proven that these two, well, we haven't quite said it yet, but we have all the steps required, right? We have an angle, and a side. So it's AAS, yep. Angle, side. However, it's asking us for something else. It's asking us to show that these two sides are congruent. And we can do that once we say that the triangles are congruent by CPCTC, corresponding parts of congruent triangles are congruent. So again, whenever you're dealing with proving a whenever you have two triangles like that, it's very common that you'll have to prove that they are congruent in order to do something like this. All right, so let me just say that the two triangles are GM congruent to triangle RGT, and we just went over that one. We just said that was from angle, side, right? Angle, side. And then finally, we can say MG is congruent to TG. And that, again, just comes from CPCTC. Okay. All right. And again, simple enough, all things that you have done in the past. So you'll do fine with these things as long as you follow the kind of similar steps. All right. One last thing I do want to say is you're probably thinking to yourself, if we can move the side outside of the two, right? Why can't I do that with the angle? Remember, we had said we could use side, angle, side, but the angle had to be between the two. Well, we can't just have like a side, and then an angle over there. And this is the math teacher joke ever, everyone's favorite. But anyway, so why can't you use side, angle? And the reason behind that kind of is illustrated in this picture. So remember, in order to show something isn't true, you'd only need one counterexample. And here's a counterexample. So we have that these two, AC and FD, these two are actually congruent. And then CB and EF are also congruent. So we have a side, and then we need an angle on the outside. Well, that's fine. We have two angles right here, ABC and FED. So these two angles are congruent. So we have a side, and an angle. However, clearly you look at these and go, they're not congruent. They're not, if I flip them over, they wouldn't be exactly on top of each other. So this is just a counterexample of why it doesn't work. Because it doesn't work in every case, we cannot use it. So that's why we cannot use side, angle, because it will not always work. All right. And the other ones will always work. Side, angle, angle, and angle, side. Those will always work. but this will not always work, and that is why we cannot use it. All right, let me know if you have any questions, and have a great day.